Hey, Village Bee, welcome to Math Notes. We took class outside today because it's beautiful outside. At least it is right now, right here where I'm at. And I thought I'd take us in front of this beautiful mural right here. That was a quote from John F. Kennedy. Today we are stepping into a brand new unit. We are in Unit 7. Remember, Unit 5 and Unit 6 were the green unit that was all on percents, ratios, proportions, all of that. And now we step into geometry. Now, geometry tends to be the most challenging unit for Math 6 Plus and formerly Math 6-7 students. But you might be familiar with many of these concepts. That's okay. We're going to review them. We're going to make sure that you have some various challenges like Tiger and King Kong levels. And you'll probably learn a few new things and master some of the old ones. So today we're going to start with polygons in the coordinate plane. You're familiar with both polygons and the coordinate plane, so we'll put them together today, and then we'll get into some more advanced things. So for today, make sure you write down polygons in the coordinate plane, and make sure that you put today's date as well. All right, so what is a polygon, and do you know what one is? Well, here's our definition. It's a two-dimensional, which means on a flat surface, a plane, closed figure with straight sides. Make sure you write that down as a definition of two-dimensional closed figure with straight sides. So no curved sides. And the word itself comes from the Greek words poly, meaning many, so polytheism, many gods. Polygon, gon means angle, so many angles. But it's more than that. Here are three shapes or figures down here. Are any of these a polygon? Well, how about this first one? Is it a polygon? Sure is. It matches. It's two-dimensional. It's a closed figure, meaning all of the sides touch, and all of those sides are straight sides. So yep, that is a polygon. How about the second one? Hopefully you said no. As you can see, not all sides are straight, although everything else matched up. How about the third one? Again, hopefully you said no, because it's not closed, even though it has the five sides. They're all straight. Excellent. So how about this one right here? Is it a polygon? No, it's not. It is not a two-dimensional figure, even though it's drawn that. It's obviously a three-dimensional rectangular prism. So it's not a polygon. Do you know what it's called? A polyhedron. All those three-dimensional figures have the hedron ending, not the gon ending. All right, how about these two? Are they polygons? Yeah, they sure are polygons, but they look a little different. If you notice on this one right here, all of the sides are congruent. And this one, all the sides are not congruent. They have different measurements. So what do we call one polygon that has all sides congruent? Well, we call it a regular polygon, regular. And if they're not, then we call it an irregular polygon. Make sure you make note of that. Regular, all congruent. That comes into play when we do perimeter later on. Okay, do you know what these polygons specifically are called? They have five sides to them, no matter whether they're regular or irregular. It's called a, hopefully you said a pentagon. These are both pentagons. Both of them are pentagons, meaning they have five sides. Right. In fact, we name the polygons, generally speaking, by their sides. So for example, we know a triangle is three sides. Quadrilateral, quad is four. Now quadrilaterals and triangles both have multiple types, acutes and obtuses and things like that. And quadrilaterals have rhombus and diamonds and kites and trapezoids and all kinds of things. And of course, the pentagon's five. What's a six-sider called? And a seven-sider? Now, you might not know this one. It's a heptagon. What about eight? Familiar with the stop sign? Octagon. Nine, easy one. Nonagon, nine, non. 10, decagon. 11, that's the one no one will have to remember. Right? And finally, 12 is the dodecagon. Now, if these are three-dimensional, we'd have hexahedron or dodecahedron, that kind of a thing. But they're polygons. All right, here we come to these two shapes. They look a little bit different. Are they polygons? Yeah, they match the criteria, no doubt about it, but they have something different about each of these that makes them different types of pentagons. One is that this has all of its inside angles less than 180 degrees, less than a straight line. Okay? We call those convex polygons, in this case a convex pentagon. Over here we've got one that has an inside angle that's greater than 180 degrees. This is less, 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 but this one is bigger. The inside angle is bigger than a straight line, and we call those a concave. Concave bends inside. Excellent. Now, this is unique. Are these polygons? Turns out they both are. Yeah, interesting, right? This is a simple one, just like what we've seen before. These ones that cross themselves, like this does, is called a complex one. Question, are they both pentagons, though? Yes or no? Make your pick. The answer is yes, they are both pentagons. They both have 5 sides. Now, some of you might be saying, this looks like a quadrilateral and a triangle. Yes, but as one whole unit, it is a complex polygon, in particular a pentagon, 5 sides. Now, one more thing, you can go to Polygon Maker and you can mess around with these angles here and find different measurements and different sides and play around and make your own polygons. And actually, it's kind of fun. I got kind of involved. All right, so here is the coordinate plane. Quick reminder, what is this called? That's right, the x-axis, and the vertical is the y-axis. And here is a polygon right on the coordinate plane. And what do we call these 4 corners here? What is the correct term? Hopefully you said they're vertices. Each one is singularly is called a vertex. Good. So question is, what are the ordered pairs for each of these? I think you should be able to find those pretty easily, but let's just a reminder, the x is labeled first, then the y, and there we go. It's our rectangle. All right, so do me a favor, would you draw, you can draw a little mini Cartesian coordinate in your journal and draw this exactly where it is. Also, can you put the little points there and write down what the coordinates are for each of those? Go ahead and do that real quick. Pause if you need to. All right, let's see what you got. For this top one, you should have -3, -1. Don't forget, we're down here in the bottom left. This one over here is, you should have -2, -4. And this one right here, you should have -4. All right, let's do one more, but this time this is how you're gonna mostly see these things. So draw one more Cartesian coordinate, please, just a small one. Get this exactly on there. Do you know what this is called? What this polygon is called? So it's a quadrilateral, 4 sides. The opposite sides are parallel, so it is a parallelogram. That's as specific as we can get. All right, but instead of points, we normally label the vertices with capital letters. So it would look something like this. So go ahead and put the vertices down, the ordered pairs. All right, what do you have for A? Yeah, 0, 0. What's the other word for 0, 0? Origin. You should have that. B, 1, 2. What's C? -1, 2. And D, what did you get it right? This one people mix up, believe it or not. You should have -2, 0. A lot of people put 0, -2, so be careful on that. Okay, good. All right, so that's our review. What you're going to do is you're going to get a piece of graph paper. Make sure you put your heading on there. Now, I gave you a copy of this exact one that you can print off from the website. But make sure you do put your name and period. I need that, please. When you get your graph paper, not your journal, a separate one, make sure you give yourself an x-axis and a y-axis. And then the instructions are there as well, but you can see the video either way. You're going to do all of these shapes following the directions specifically. So for example, in quadrant 1, hopefully you know which quadrant's which, you're going to put an acute triangle. If you don't know the definition of something, look it up. Go find out what it is. If you do, you're good to go. An acute triangle in quadrant 1, and make sure you are giving the ordered pairs for each vertex, please. Got it? And then I would say label it A, label A. Put a square in quadrant 2, rectangle in 3, trapezoid in 4, parallelogram in 1, but here's the rule, one of its vertices on the origin, and so on and so forth. Please label each of these with a letter and make sure you put the ordered pairs. And you can go to check out more information on polygons here, Con Polygons, polygon types and polygon skills with great little videos, quizzes, and lessons for you as well. And one of them leads to something that looks like this, which I think is pretty cool. It shows you regular, irregular, the names, concave, convex, complex, and not. So go ahead and take a look at all of that. Make sure you know your polygons, and we're hitting into geometry. All right, we'll see ya. I'm gonna go hang out in North Court a little bit more. Bye.